Hello everyone. We have a question which says that a particle of mass 0.3 kg over here is held at rest. Rest means equilibrium by two light inextensible strings, and the two light inextensible strings is this one and this one. One string is attached at an angle of 60 degrees to the horizontal ceiling. This is a horizontal ceiling, and one string is attached to the particle making an angle of 60 degrees to the horizontal ceiling as per the statement. The other string is attached at an angle of alpha to the vertical wall, and this is the other string. It is attached to a vertical wall making an angle of alpha. The tension in the string attached to the ceiling, that means this wire, is 4 Newton. That means over here the tension over here is 4 Newton. Find the tension in the string which is attached to the wall. That means this is a wall, that is a ceiling, this is a ceiling, and this is a wall. Over here the tension is 4 Newton. According to the statement, find the tension in the string which is attached to the wall. So basically we have to find the tension in this string and find the value of alpha, and we have to find the value of alpha. Basically we have to find two things: the tension as well as the value of angle which is alpha. Because the condition that they have given us in the question is held at rest, that means an equilibrium condition. For that, definitely we have to split them up into horizontal and vertical components. But before that, we have to understand what the horizontal and vertical components are. We have seen that most of the students make up a mistake, and they have a misconception that the horizontal component is always a cos component. No, it is not like that. If the angle is with the x-axis, then the side next to that would be a cos component of that particular force, and the opposite would be a sine component of that particular force. But if the angle is with the y-axis, then the side next to that would be a cos component of that particular force, and the opposite would be a sine component of that particular force. So it is basically based on the angle, where the angle is it with the x-axis or y-axis. Based on that, we could decide the component as cos or sine. So if we label the diagram very clearly according to the components, this 60 degree and this 4 Newton is the tension in the string. So definitely this 60 degrees with the x-axis. So over here the horizontal component would be 4 cos 60 and the vertical component would be 4 sin 60 pointing upward. And in this over here in this wire, the tension, definitely we have to find this value. The angle alpha is with the vertical, so definitely this side would be a cos component of this particular tension t cos alpha, and that would be t sin alpha. And the mass of the particle is 0.3 kg. Multiply it by 10 to get the weight, because weight is equals to mg, mass into gravity. So 0.3 multiplied by 10 would be 3 Newton, and this 3 Newton is basically the weight. Now because the condition is held at rest, that means equilibrium condition, so definitely we have to get the two condition based on horizontal and vertical component. If we just work out with the horizontal component and look at the diagram, we can see that the two horizontal components, which are 4 cos 60 degree and t sin alpha, and they are in opposite direction. 4 cos 60 is to the left and t sin alpha is to the right, and because the condition is held at rest, that means equilibrium, that means 4 cos 60 would be equal to t sin alpha, as we have written over here. T sin alpha is equals to 4 cos 60, and 4 cos 60 is 2, so t sin alpha is equals to 2, which is our equation 1. From the vertical forces, if we just look at the diagram, we can see we have one vertical force pointing upward, which is 4 sine 60, and we have one vertical force pointing downward, T cos alpha, and the weight of the particle 3 Newton, it is also pointing downward. So based on the condition of equilibrium, the opposite forces are equal. That means the sum of these two, the T cos alpha and 3, would be equal to 4 sine 60, and we have written the same T cos alpha, this one, plus 3 would be equal to 4 sine 60 over here, and 4 sine 60 minus 3 is 0.464, and that is equal to T cos alpha, which is the second equation. Because in the question they asked us to get the value of T, which is the tension over here, and the value of F, we have the two equations. We can use the two equation and easily get the value of T and the angle alpha. We have two different methods. The first method is dividing equation 1 by 2, that is dividing T sine alpha by T cos alpha would be equal to 2 divided by 0.464, and when we divide T sine alpha by T cos alpha, we could cancel the T, and after cancelling the T, we have sine upon cos, which is 10, and 2, which is over here, divided by 0.464, that is 4.31. Taking the tan inverse of 4.31, the value of alpha is 76.9, which was the requirement of the question. Find the value of alpha. Now place this value of alpha in any of the equation, whether equation 1 or equation 2. For example, if we take equation 1, which is T sine alpha is equals to 2, we have the value of alpha is 76.9. So T is equal to 2 divided by sine alpha, and alpha we know 2 divided by sine 76.9, and the value of T is 2.05 Newton. So this method is super easy. We do have another method also, which is also very easy, that is squaring and adding equation 1 and 2. Equation 1 is T sine alpha is equals to 2. Equation 2 is T cos alpha is equals to 0.464. Square them and add them. So first of all, square them, T sine alpha square and T cos alpha square, and then add them. That means 2 square plus 0.464 square. After simplifying 2 square plus 0.464 square, we have 4.215, and opening up the bracket, which is T square sine square alpha plus T square cos square alpha. Taking T square as common, we are left with sine square alpha plus cos square alpha in the bracket, which is an identity equal to 1. We are just left with T square equal to 4.215, taking square root, and finally we have the value of T as 2.05 Newton, which is the same answer that we got from method 1. Now placing this value of T in any of the equation, whether equation 1 or equation 2. For example, if we take equation 2, T cos alpha is equals to 0.464, placing this value of T over here and then dividing it below 0.464, we have 0.226. Taking the cos inverse of that, 0.226, that would be 76.9 degree, which is the same answer that we got when we were working with the other method. Both the methods are super simple and easy. You can use any one method in the paper and get your answer.